Hi everyone, in this video we will explore scale factors. We'll firstly have a look at what ratios are, we'll then build our way to scale factors. So ratios compare values and quantities of the same unit. For example, the number of teachers to students in the classroom can be 1 to 25, meaning there's one teacher for 25 students. Therefore, 1 to 25 is not the same as 25 to 1 because one teacher to 25 students, then 25 teachers to one student is not the same thing. We could rewrite this ratio as a fraction, and that would be 1 over 25. Now, when we're drawing, when we're representing an object in a drawing, we either enlarge or reduce the image. So for example, Google Maps. So to construct a drawing, we need a scale factor. A scale factor can be written as the following. So scale factor equals to image, which is the drawing, length, over the actual length, and this is always the case, it's not the other way around. All right, so for example, I could have 5 millimeters and the actual can be 1 centimeter. So then I need to convert 1 centimeter to millimeters. That would be 10 millimeters, And then I need to get rid of the millimeters, so it would be 5 to 10. I need to divide both sides by 5. That would give me 1 to 2, so that would be the scale factor. So every 1 millimeter on my graph will represent 2 in real life. So if a scale factor is 1, this means that there is an exact duplicate, so the image is the same as the actual object. If a scale factor is greater than 1, there's an enlargement, so the image is greater than the actual object in real life. If a scale factor is less than 1, there's a reduction, meaning that the image, the representation, is actually smaller than the actual object. So let's quickly have a look at this example. We have a scale factor in areas. So first thing first, we want to find what the scale factor is. So let's call this rectangle A, let's call this rectangle B. So in order to get from rectangle A to B, what am I doing to the side lengths? Well, this side over here, I'm multiplying by 2. Let's say if multiplying by 2 to this side length will give me this. In fact, it does. Therefore, my scale factor is I'm multiplying by 2. So my scale factor, or K, is 2. Now, I want to find out, because this scale factor is for length, I want to find out what happens to the area. So let's find the area of rectangle A. That's going to be 3 times 2 centimeters squared. That's 6 centimeters squared. Let's find the area of rectangle B. It's going to be 6 times 4 centimeters squared, and that is 24 centimeters squared. This time, going from 6 to 24, I'm multiplying by 4. But I could rewrite this using my scale factor as 2 times 2, or 2 squared, meaning I have K squared. So we could then conclude that when all dimensions are multiplied by a scale factor of K, the area is multiplied by a scale factor of K squared. So the area is enlarged by K squared, and the volume is enlarged by K cubed. Let's have a look at a few examples. All right, so I want to find the ratio of the side lengths. So let's call this A, let's call this B. We're going to go from rectangle B to A. Remember, this is the image and this is the actual. So it's always image over actual, our scale factor. So rectangle B to A, if I have a look at this, it's 25 to 5. I'm going to do B to A again, and that's going to be 10 to 2. I'm going to divide both sides by 5. That gives me 5 to 1. And if I divide this by 2, that also gives me 5 to 1, meaning that the scale factor is 5 over 1, or just 5. So I need to multiply rectangle A by 5 to get to rectangle B side length. Let's write this down again. K equals 5. Now I want to find the ratios of the area. Well, if the side length K is 5, we know that for area it has to be K squared. So it has to be 5 squared, which means it's 25. Or you could write that as 25 over 1. All right, let's have a look at another example. Over here it says, determine whether the first shape has been scaled up or down to give the second shape. So are we enlarging or are we reducing? Remember, this is the actual, and this is the image. It's the one that's scaled. So let's have a look what's happening. I'm going from something large to something small. So again, that's A, that's B. B to A is going to be 2, so over here, sorry, large to small, therefore there is a reduction. So let's just make note of that. So it's scaling down. Now I want to find the scale factor. Remember, the scale factor is always image over actual. So I'm going to do my side length 2 to 3, and I'm also going to do my other side length just to make sure that it is the same. Divide this by 2 and it should be the same. That's 2 to 3. So therefore K is 2 to 3. That's my scale factor. This is what is the scale factor of the area. Now, given the scale factor was 2 to 3, the scale factor of the area is going to be K squared. It's going to be 2 over 3 squared, which is 2 squared for 3 squared, and that gives us 4 over 9. So therefore the scale factor of the area is 4 over 9.